In this tutorial, we are not going to be doing geometry nodes, but we will still be doing procedural modeling. We're going to be using Sverchok today, which I know if you've watched some of my older videos, then perhaps you might have seen already. A lot of people won't know what this is, but will be more kind of open to it, I think, now having experienced geometry nodes. In this tutorial today, we're going to be looking at Phyllotaxis. So if you've had a look at my splash screen videos, or if you have played with my toolkit, you've probably come across the Phyllotaxis node in there for geometry nodes. And if you've had a look inside, you'll know that it's a long line of nodes. We can make the same pattern much more clearly, much more how we're used to doing so with shaders, working with nodes and shaders. So that's what we're going to do today with Sverchok. Let's jump over to the screen. So Phyllotaxis, what is it? It's most commonly seen in plants, and we see it all the time in like flowers, the arrangement of petals, the arrangement of seed heads, pine cones, the way that sprouting plants like with a stalk will have leaves coming off, the rotation of the leaf per leaf, right? And it's to do with how much light they can get to the leaf. It's supposed to be the optimum amount of like light per leaf so that they can photosynthesize as best as possible. Or with flowers, it's just a very dense arrangement, so it's good for seed heads and things like this. So in Blender, if you've seen my geometry nodes ones, you'll know that I have like my 3D viewport, geometry nodes, and a spreadsheet. And when I'm working with Sverchok, I have it set up a little bit differently. And this is because Sverchok can be more in parallel, which is the common complaint for geometry nodes is that it's too linear. And with Sverchok, we can actually branch off and do things as you would think. So this is why I have my larger node space for this. And I would recommend if you're setting up a Sverchok workspace, you would do something similar. What we're going to be doing is creating a number of points, and the position of these points is going to be offset by two things. So each point has to be rotated around in a spiral. So a spiral has two things. You have the angle as you go around, and the main Phyllotaxis is 137.5 degrees, but you can change that to be whatever you want. So that's your offset per point. And then we also want to have a radius offset. So if we didn't have a radius offset, then you would just go around in a circle. But with a radius offset, then we can extend outwards basically to give us the spiral. So let's create a new node tree here. First thing I'm going to do is I'm going to add a vector in. And if you want these icons on your menus, which I really like having, if you just go to your edit, preferences, add-ons, go to Sverchok, and you can turn on show icons in the Shift A menu. So that is what I'm using there. So let's add a vector in. And if I Control Shift left click, then we can see visualized our point there. So this creates it's called a temporal viewer, which just means that it's not actually real geometry, it's an overlay. But we can use this to just help us visualize things as we work through here. So if you haven't worked with Sverchok before, don't worry, we're going to be working through quite slowly here. Basically, we have this vector in, and you can see that it is generating a point with these coordinates. And what we can do is we can send in like a range of numbers to create a range of points. This is different to geometry nodes where everything is like attached to geometry, whatever that means. In this case, we're just reading the vector as a vector. So let's take a number range in here. And this is kind of the heavy lifting node. This is the one that is going to generate all of our points. So to begin with, let's change this over to step. We want a step size of 1, and then we can control the number that we have the count. In geometry nodes, when we take a line node with a 1 meter offset and then a separate XYZ, and we take our like index as the whichever axis has the offset, by default that would be the Z axis. This is just doing that, right? So if I plug this into my X, then you can see that we have a 1 meter offset per point, and it's just generating 10 points or 11 or whatever. And I can just change this in here. How would we turn this into a circle? because we've done circles, and if you look at the spirograph video for geometry nodes, that's how we make circles. It's a little bit easier with geometry nodes, with Sverchok, because we can just add a scalar math, change it from multiply to sine and cos, and then there we go, we have a circle. And we can just set the number of points on there. So this is kind of most of what we have to do. The next thing that we need to do is sort out those two offsets that we were talking about. So we have our angle per point, and we have our radius per point. To begin with, let's start with our angle per point. Now we're going to need a number range in with a 1, like a step size of 1 for doing another part of this, for doing the radius. So for now, let's just keep this how we have it here, and we'll multiply it by something. We'll multiply it by the angle that we want. So at the moment, we're getting if I reduce this to 1, and then we go to 2. So this angle here in our 3D viewport, this angle is 1 radian, right? So 1r. And that angle is about 57 degrees. So what we want to do is we want to multiply this 1 by whatever radian angle is 137.5. We don't need to know this. We have in here, we can just change this over to radians, type in 137.5 like so. And now the output of this is going to be in radians. You can see 2.4. If I just Control Shift left click on there, it's going to generate a stethoscope, which is like a little text viewer here. And you can see the number is 2.4. So the number we want is 2.4. So let's take a multiply in here, where we multiply, and let's just multiply this on there like so. So now instead of being that 1 radian offset, we now have this 137.5 degree offset. And if I add another point, and you can see that these just keep going around the circle. Great, so this is our angle offset. Let's just pull this out. I'm going to put it in a frame called angle. We now need to work out our radius offset. This again is actually not too challenging. The easiest way for us to do this is to scale our vector, right? So if I add a vector math node here, and I change it from component to multiply scalar, then now what we have is a vector being multiplied evenly by our scalar or our float. And you can see there that just changes the radius. So instead of putting in a constant here, I would like a different value per point. And we could do something even very simple here. I could just take my number range directly, plug it in. And if I zoom out, you can see that is it is a spiral. However, we want a little bit more control, and there's a specific fall off that looks really good, and it gives us an even packing. What we need to do is we need to take a 0 to 1 range, because at the moment, if I set this to 1 on my scalar, then we have a radius here of 1, which is nice and easy for us to work with. So we want to keep that. So I want the maximum number that we multiply by to be 1. And to do this, what I'm going to do is I'm going to create a factor output, essentially a 0 to 1 range across all of these points. If I just add a a text, viewer text Mark 3, and I'm going to turn off frame, turn on auto update. Let's bring this up in our viewer here. So this is just a regular text editor that we can view the Sverchok viewer. And we have points, as you would expect. A 1 offset with 51 points is going to go from 0 to 50. Remember, starting at 0, so ends 1 below our count. So if I was to take this range and divide it by the total number in the set, 51, then we can have a range of 0 to 1, more or less 1 anyway. So let's add another math node here, scalar math. I'm going to set this to divide, and I need to take my number here as a separate number. So let's add a number, just a number. Change this to integer. And now I can set this up to 51, which is what we have already. And let's also plug this into our divide. So now on our viewer, we can see that we have this range of numbers up to 0.98. 0.98. To be more accurate, if I was to set this to 50, then it would be perfectly up to 1. So I should do like a subtract 1. But it doesn't really matter for what we're doing here, because when we sort out the radius, we're going to do it analytically, right? We're going to look at the list maximum value. So it's not like compulsory that we have it go up to 1. It would just be like more accurate. Yeah, okay, let's do it. Let's do it the proper way. Right, let's grab another scalar math node, subtract 1 from it. There we go. Conscience is clear. So 0 to 1 range properly going in there. And if I was to now plug this into my scalar, you can see that the maximum radius hasn't increased. All that's happened is the inner ones now scale down to 0 in the middle. Now let's increase the number of points here. And you'll see we get more points. So let's just reduce the size of our viewer. We got to change the fall off because at the moment they're really dense in the middle. If we go back to our preview here, what we're aiming for is something that's fairly even. However, I will acknowledge that real flowers do actually have a size fall off depending on the size of the innermost ones, right? Because they grow and then they get like pushed out as they grow. So they are increasing in size as they go out. Back to here, what we can do therefore is we can add a power. And because we have a 0 to 1, if you do a power like squared, so to the power of itself, or sorry, to the power of 2 being times itself, then where it's 0, it will stay at 0. And where it is 1, it will stay at 1 because 1 times 1 is 1. So what happens when we do a power on here is we can get a curve either one way or the other, which is very useful. If we have a 0 to 1 range, we can do this quite predictably. If we were just using the full range, like without doing this divide beforehand, then, you know, a value of 50 times 50 would be 2,500. So that would be vastly greater range than the original range of 50 is now going up to 2,500. So splitting this down into a 0 to 1 range means that when we do our power, it's going to stay within the same range, right? 1 is never going to be greater than 1. But it's just the values in between basically become more or less up or down with a bit of interesting fall off. I'm probably not explaining this very well. Let's just grab a power by y. And here we go. If I change my y value up, you can see that we pull into the middle. And if I change it down, you can see we push out from the middle, and it feels about right somewhere around here. Let's have a look. So that's 0.54. 0.5 is actually what we're after, which is the same as a square root. So to the power of 0.5 is actually the same as doing a square root operation. So you may want to have yours flexible here, depending on, you know, if you wanted to have different size in the middle, then perhaps you'd want more densely packed. I'm just going to keep mine to a square root, and for that, I will actually use the square root function. Already we have basically all of our points in position. Now, another thing which is very useful for us if we are doing flowers is to be able to expand the middle. Because if we have petals and they want to come out from the outside of the seeds, right? So they want to come out from the outside of the seeds. They don't want to start in the middle of the circle as well. Very simply, we can just add another math node in between our divide and our square root. And if we change this to add, here we go, then you can see that we can push that out from the middle. Now, this is where we're going to do something that's a little bit more advanced than the geometry node setup. What we have already is basically what the geometry nodes 1 can do. However, we can make it go even further with Sverchok because we have some analytical tools in here. So what we want to do is we want to make sure that we are scaling our positions down a little bit. So I'm going to bring this one down here, Control J, call this one expand, And that gives us our expansion. Plug that in. So you can see that our outermost points get bigger, get further away. So our radius isn't controlled. We can set our radius to begin with. However, by the time we've scaled everything or expanded these points outwards, then we are no longer maintaining a radius. And that's kind of problematic because you might have something very specific, or like, especially if you're doing an architectural project, you may be like, this site only has 10 meters and I have to position these things within 10 meters. And I also need some space in the middle. So you can't have it set to 10 meters and then expand in the middle and have the outside push out. That's not acceptable. This is the great thing about Sverchok and being able to work in parallel. We can take our values here, right? And we can find the length of them. This is going to tell us what the radius is. So I'm just duplicating my vector math here, or if you want to grab it again, it's under vector math. So let's grab a length operation. And now you can see in our viewer that each one of these values within our list has been, the length of it has been calculated. So that's very useful. We can find out that our final one, if I set my expand back to 0, our final one is a value of 1, which is perfect because this is, if we were to multiply this, right, by any value, then that value that we multiply by becomes our radius. However, as I expand, now we're at 1.4. So what I can do is I can find my length on here, and I need to grab my list. In geometry nodes, we will be getting attribute statistics. So this process that I'm doing now will be available in that system. So I've just added the list statistics node here. And what this does is it basically takes all of the values within your set, within your list, and it does some form of calculation. There's a lot of useful things in here, very useful things. And the one that we are interested in right now is maximum. We want to find what the maximum value is. And make sure, by the way, if you're looking at the name here and it just says maximum, you just want to switch it over to value. So we can find out that our maximum value here is 1.4142. And I need to find out what you would need to multiply that by to get 1. So let's take a divide here. And if I put my value into the bottom, and that now I have a divide number in the top, and we can see that value is 0.707. Let's make that a bit bigger. So take another multiply scalar. And if I plug this in here, set that back to 1. So now our radius is always going to be whatever value is in that divide. So you can see that doesn't change the outside radius. Just the maths here. I know it can be a little bit confusing, like why do we divide it by something? And then, but the reasoning is, right, we've got x essentially coming out of our list statistics, an unknown value, or a known value but changeable. And what we do is we divide 1 by it, and then we multiply it by this range here, which goes from 0 to x. So that ends up with it being like this, right? So x, and any value which is just a value, we can also write as being that value over 1, right? So anything divided by 1 is just itself. This value here, of course, could be any number. But the great thing about this is that because we're multiplying, we can also cross-simplify. So these both simplify down to 1, and there we go. So now we have our number that we input to the divide over 1 just means our value. So it's a nice, easy way for us to just make sure that we're getting the value that we want on here. And let's pull this out as like a controller as well. So let's call this one radius, and it's a float. And we're just going to set this to 1 to begin with. And let's plug this in to the top of our divide. Division is one of these things which it matters which order you do it in. So radius into the top, and our list statistics value goes into the bottom. Cool. So this is basically how you make Phyllotaxis. We're going to make an actual flower in just a sec, but I just wanted to kind of take a pause here just to show that it's not crazy difficult. You can do it with just a few nodes. I really like Sverchok, it's great. I know some people have been asking if I'm going to continue with Sverchok content now that Geometry Nodes is here. And the answer is yes, I absolutely will be. I've got a few projects planned for Sverchok, got a course planned for Sverchok as well. Just needs me to sit down, record, edit, script, do all of that fun stuff. but that should be coming this year. That is the plan, sometime in autumn. So here we go. Here is our thing. I'm going to show you how to make it into a group node, because group nodes are reusable. You just add them, append them, or link them as you would any node group. So let's copy these nodes, and I'm going to add a group node in here. Hit new. I'm going to paste in these nodes here, and we can just do something like this, right? So we can connect these. You can say, you've got integer values in here, making sure that these are sort of expected values. Let's change this to count. If we view this, then you can see what's going on there. So it's literally that simple. I could just go through here, add the angle here. And you can see that we're just working through. This is just the same as any node group. Great thing about these value nodes is that you can plug directly into the back of them. So this one was radius. So there's a couple of extra things that may be worth just adding in here that would be very useful for a group node. So one of these things is having the VAC value, right? This 0 to 1 range. I want that exposed. I also want the number of points to be exposed. So now I've got everything in here. Let's just make this space full size. If I am in here, our output, we have our vertices, and let's also grab our count value. So that's very useful. And our fall off, which comes from this divide, this one just after the number range, divide, join that up like that. And I'm just going to call this one fac for factor. This is already looking pretty good. We got our nodes. If you are interested in the nodes themselves, the screenshot will be in the description if you want the access to the full screenshot. I've also put the full file on Patreon. So if you are a Patreon, actually I'll put it on for free. So it doesn't matter if you're a Patreon supporter or not, you can just download this. I think I would probably do this with most of the Sverchok ones because I think it's a really good platform that people should learn. If I change the name from Sverchok group here to Phyllotaxis, if I was to just save this here and then in a new version of Blender, I can jump in here. Obviously I don't have anything at the moment. This is just a new file, but I could append from the one that we just saved. Node tree. You can see that we have Phyllotaxis in here as a node group that we can just append. And it's a little bit confusing, like, oh, it doesn't show up on this group list, but you add group node and then you search here, Phyllotaxis, and there it is. All of the controls as we expect. So that is how you append and reuse node groups, just like normal in Blender. Let's do a couple of things. Now we have this node group, we can start actually making flowers and things. So we're just going to make a simple daisy. The workflow is just the same as we use for geometry nodes now that we have the node group. More or less. Actually, no, there are some differences. There's definitely some differences. Don't listen to me. So this petal that I've just added here, it's very simple. It's just a few vertices. It's just a plane with some subdivisions scaled and bent around a little bit. And then I've just subdivided, displaced, solidify, and subdivide again. And that just gives us quite a nice little petal. Certainly good enough for what we want today. So what I'm going to do is I've got my Phyllotaxis node group. It's just the same as these nodes. And we need to basically position our petal on all of these points. And there is like dupliver if you go into scene duplicate instancer. We're not going to be using this one. I'm going to be using objects in. Let's grab select the petal, get selection. Just for ease to begin with, I will turn that on at the end, but just for now, I'm going to leave it off actually. So you can see what that looks like, the difference there. Now you might be like, why is this in a different place? And it's because I haven't applied the location, right? But if you control the matrices, then you can see that it moves it around. Now this is fine. We actually want to create custom matrices based on our points, and you can see what goes on there when we do that. Let's jump in here. Right, the center that we want these to come out of is going to be around about the length of one, and these are, let's go 0.2, sorry. So it's halfway there. Just so it's approximately third and third, right, for petals and center. And then we can expand the middle. There we go, something like this. And now all of our petals are going to come out from that center, from the points and it's going to give us space in the middle for our seeds. If I click this little button, right, and you'll see this on some nodes, if I click this, it will generate a matrix. Or if you had, for example, a vector, then you can click it and it will create another vector. This may not be useful in this case, but we are interested in the matrix in. And I'm also going to change the viewer. So instead of a temporal viewer, we're going to use a viz mesh viewer. Now we have an actual mesh object. And if I want smooth shading on this, then I have to select my mesh viewer, press N, and go smooth shading on the side there. Now what I want to do is I'm going to plug my matrix into here, and I'm just going to plug my positions into that location. Now, there's no rotation. This is one of the issues that we face. We would like there to be proper rotation per point. I think this is the easiest way. So if we have a point, let's just draw a point here like this. If we want to work out what the angle is to this point, right, theta, and what we have is its position. We have its x value and we have its y value. What we can do is we can find out from tan, right? We can work out if tan theta is equal to opposite over adjacent, so y over x, then to work out what theta is, we can take arctan or atan of y over x is equal to theta. And conveniently, there is an operation which sort of does this, and that is the atan2. And you'll see this in the math node, in shaders, in the math node here. So let's take a vector out, and we can basically take our vector to pieces so that we can take our y and our x values from each one of these vectors. And just remember that this is a list, a long list of every single point. We can then take a number scalar math, find atan2, so arctan2, and let's just plug these in, x and y, here we go. And let's plug this into angle. Something's happened, but it's not enough. And that is because angle wants degrees, and atan2 here will be outputting radians. So let's take another math node, set this to degrees, and I can just plug that on there. Boom. That's perfect. That is exactly what we wanted. So this is our Z rotation. We also want to control our Y rotation? Yeah, our Y rotation. Let's just move things out, give us a bit more space. Right, so on our matrix, at the moment we're going with axis angle, and you can see axis is Z. Let's change this over to Euler, and this means that we now have separate X, Y, and Z. Let's plug this into our Z, and we can now control our Y rotation separately. Our Y rotation is going to come off our factor. So the factor is 0 to 1 range per point. And we basically want ones in the middle, or ones that have a lower factor, to be sort of rotated up a little bit. And then ones on the outside, so have a higher factor, to be rotated down a little bit. Easiest way for us to do this is with a mixed number node. So number, there's actually mixed numbers and mixed inputs. I'm just going to go with mixed numbers here. Take our fac into the factor, take our value into our Y rotation, and hopefully, yeah, there we go. So you can see that value 2 and value 1 control the top and bottom surface, or sorry, the top and bottom petals here. We're going to want to do something with the scaling as well, but just for now, let's make sure that we've got something somewhat appropriate. Definitely too many petals for just like a daisy. There we go. Something like this is probably fine. Could probably even go fewer petals. And I might turn on the post modifiers, and that just gives them interest. That's looking okay. Now let's do one for the scale. So let's bring this down a little bit further. Just a bit more space. Let's grab, if I was to plug my factor straight into the scale here, then you can see that we basically have 0 scaling in the middle, 1 like full size on the outside. We want to just search for the curve mapper, and let's drop this on here. This can be used quite simply. It does not automatically update, by the way. You have to like click update, or else you can just play the animation, right? Play the timeline, and that will force it to update. So I'm just going to make the middle ones very slightly smaller here, something like that. So this is our sort of main matrix. It's controlling the angle of all of our petals. How about we do a random rotation to angle X? Because angle X is like the tilt on these, and it might be nice just to have a little bit of like positive, negative tilt on there. Let's do the same thing, right? Let's grab a random number generator. I want my numbers to be floats. I want the size of this set to be the right size for the number of petals. So I'm going to take my count here and plug this into my size. Float low is going to be -1. Oh wait, no, angle in degrees, right? So let's go from minus 8 to +8. I'll do -8 to 8. And let's just plug this in here like so. You can see if I change the seed, then we just get a little bit of movement on there. So the great thing about this is it was probably going to give us a little bit more interesting lighting if we have some decent lighting on it. And you can see it's just changing the illumination on there. Now at the moment you can see each one of these petals is individual, and I'm just going to hit merge on my mesh viewer, turns it into one object, and then you can see that we can move it all together. That's nice. Next thing I want to do is jump back into solid view. Let's add our seeds in the middle. This is basically the same process. Now this is one of the things which I love about Sverchok, is I can make multiple objects from the same node tree. I don't need to make another node tree. I can just create another mesh viewer, and it's going to output to a different mesh. So I can name this first one petals, and we can make another one called seeds. Now it says list index out of range just because there's actually nothing going into it. Let's plug that in, and it's just generated the points to begin with here. Now I don't want to expand at all because we have seeds, right? We need this to cover the middle. I also want to increase the number, something like this. I might make the radius slightly bigger just so it's cutting off the base of those petals. And we're just going to do a couple of simple things. So let's grab another matrix here. These are going to go into our locations, and I want to add a generator, icosphere. This is going to be our actual object. So here we go. Radius is going to be much smaller, so 0.01. Yeah, that's actually probably quite good. I'm just going to change this down to like 600 for my number of points. At the moment it's flat, we can change that. And it's also got equal scaling across the whole thing. So first of all, let's deal with the flatness. The easiest way for us to do this is just to add basically to our Z position. Right, so let's grab a vector math node, add. Now you can see if I add something onto here, we're just moving this up and down. You can see at this point, even though it's very simple, the scene that we have, the performance is already starting to struggle. This is just an issue with Python, but you can still create very complex things. And I also recommend doing Sverchok with geometry nodes, right? So if I was making a more complex system, then I may do something like Phyllotaxis and generate my points here. If I were just to plug that in there, then you can see I have points, and then I could go into geometry nodes and I could instance on those points and take advantage of the speed of geometry nodes. In this case, we're just doing everything with Sverchok because I think there's maybe not enough exposure to Sverchok out there. And yeah, it's a great system. So we want to add something to the Z position. If I was to just add a vector in, so this creates a vector, and then I was to plug my factor into the Z height, then you can see that we have this kind of shoot of points. Not what we're after, but you can see that we have information that we can control. So let's take another curve mapper. So search for curve mapper, and I'm going to put this on here. And instead of having to like navigate this to be nice and low on here, rather than that, let's just change the clipping limits here. So my maximum Y, I'm going to set this down to something very low, like 0.2. Hopefully that's low enough. Update that node. Oh, that's definitely much too high. Let's go even lower. 0.1 update. That'll do. And we actually want to go the opposite direction. So let's do that. And now you could totally leave it like this, right? However, I want to have a slight indentation in the middle. A little bit of a dip on here. Something like that. Maybe a little bit less aggressive. Something like that is probably okay. And I'm also just going to control the size of these as well, according to the fall off as we were before. Sorry, the factor. So I can do that very simply with just another curve mapper, press backspace on it to reset it, select my factor into here, this into my scale, and we're going to bring this up a little bit, make sure it's not completely zero in the middle. And I'm going to make it increase quite quickly, and we're going to go for a few more points. Now this is kind of why you might want access to I said it to square root before, but you may want access to that power. So if I was to add that in here, so let's change this to power Y, and let's plug that in here. Let's make sure that we have something sensible, so let's call it exponent. Default value of 0.5, just because that's square root. So there we go. However, if you were to increase the value, then you can see it increases the packing density in the middle and reduces it on the outside. So it's a sort of relative shift towards the middle. Another thing you may want to do is to lift the petals slightly, just so they're not cutting off on the edge there. So I might just add vector math, grab onto the location here, change it to add, and let's just change this to like 0.01, something like that, just to bump it up slightly. So this is looking quite nice already, somewhere between like a daisy and a sunflower sort of thing. It's that simple. I know this might actually look quite complex, but once you get into using Sverchok, especially if you've been using geometry nodes, then, you know, this working in parallel, just thinking about like what you need to add to what, rather than thinking like which attribute you need to work on. In fact, if I just show you my my geometry node setup for Phyllotaxis, so obviously you get all the edges as well, but if I look in here and I'm trying to work out, like as I was earlier today, to make sure that I was doing the right process, trying to work out what's actually going on where, and obviously I have these string nodes because I need to be able to remove attributes at the end to clean up the spreadsheet and stuff like this. And I'm going through like, okay, I've got the multiply, but it's being multiplied by, and I have to like follow the noodles. It would be a little bit simpler, obviously, if I was just using regular names, you know, like index or angle, like I actually am doing here. However, it's still very difficult for me to read this. And you know, I've got sine going directly into cosine, and in terms of the logic, that's totally wrong. Sine and cosine are in parallel. They shouldn't be one after the other. And then if we compare this with geometry nodes, and it's like, oh yeah, I see, I took my thing, parallel sine and cos comes out. I did my other thing, multiplied it over here, branching this for my radius, my final radius control, like analytically. There's just a lot of stuff which should make things a little bit easier. If you're coming from geometry nodes to Sverchok, you'll probably find it quite refreshing. So there we go. This has been a pleasure, as always. I want to do more Sverchok tutorials. Let me know if you like this kind of content where it's a little bit more kind of freeform. I'm not going to super edit this. I know that people struggle when I over edit videos. So I'm just going to leave this a little bit, hopefully more approachable, more follow alongable. Thanks for watching. Hopefully this has been useful and informative, and I will catch you in the next one.